Assalamualaikum. So today I'm going to present on the project of for computer and network security ECC 4707 on the topic of the C.O.W attack. So my name is Nodalili binti Muhammad Joan Chua. So I'm going to present for the first part, and the second part my teammate, which is Lim Tiong Seng, will present it. Let's proceed. So the objective of this project is to experience under the C.O.W attack. Student will gain understanding on the risk condition vulnerability exploited by the attackers, which used to get the root privilege. So I'm going to introduce for the C.O.W. So the C.O.W was found by Phil Oster on 2016. It stands for dirty copy on write, which comes from the copy on write mechanism. So a risk condition vulnerability, which is a security issue that attack any devices that use Linux operating system. It elevated the root privilege by utilizing risk condition on Linux kernel. It gives normal user an access to write in read-only memory mapping and ability to modify the whole system. So I'm going to explain it about the copy on write. So basically, the copy on write mechanism set out the copy of the write file and allocates in a new physical memory location and makes it pointing into separate location of memory. So in simple term, so in this diagram, this is before the copy on write mechanism is applied. So the processes which is in logical memory, we're trying to write to physical memory and basically pointing to its memory in the page of memory in physical memory called page. So like maybe this is process A, B, C. So A will be pointing to page A, page B, this one is page C. So after the copy on write mechanism is applied, the page of C, as you can see, the page of C, when the process of C wants to try modify or write something to the physical memory, the kernel comes in action and makes a copy of the physical page, in which, as you can see, it makes a copy of page C. So it makes a copy into another separate location of memory in the physical memory. So there will be two page C in the physical memory. Thus, it makes the new update will be on the copy of the memory instead of the original one. So it get overwritten from the copy on write in the physical memory. So the update will be on the copy of page C. So basically that's how copy on write mechanism works. So the thing that we need for this project is VirtualBox. So we need to install it to open the pre-built virtual machine of Ubuntu Linux, because we use the Linux kernel operating system. And then we also need to check if the virtualization is enabled or not. As for my case, my laptop is not configured yet, so we need to enable back the virtualization configuration first. So basically in this project there are two tasks, which are task 1 and task 2. Task 1 is to change a dummy read-only file. So we use the given the C.O.W program called attack.c file to attack the read-only file. The aim is to change the number 2222, this one, to this asterisk. So for the task 2 is to gain the root privilege by changing password. So we modify the given attack.c file to attack etc password. The aim is to change the user ID from any value into a value of 0, which is the root, so that any user can get the root privilege.
Now I'm going to talk about the result. This is task 1. We using a dummy read-only file and run a count at .c, and this is the result. And we successfully replace the 2 become a star. Task 2, we use a file called etc passwd. This is the content of the file, and you can see the top one is the root user with UID 0. So remember, user root has 0 UID, and the seed UID is 1000. Okay, and next we want to create a new user, and the new user name Charlie. is user ID is 1001, and we run a file count_attack.c again, and we successfully get the result that we want. Okay, so talk about the discussion. From that two tasks, we do the decal exploit, and we using terminal in Linux OS and run a count_attack.c. So this whole process for the attacker to get the root privilege and thus compromise the whole system. Okay, so this is the main thing we want to discuss for this topic. Next, the count_attack part 1. This is the main function, and I want to highlight this one. Is going to open the target root file first as read only. You can see this one ORDONLY is the flag we indicate read only file, and we use this line to map the root file to a virtual memory. So you can see this mmap, we use the map private, means that the original file is the read only, so we use map private to enable count on write. Okay, this is a whole process to allow target file to use count in the virtual memory. So this is the part 2. We highlight this line to open current process memory. So we know that Linux will do any process will need a file. So here we open this file to do write, and for this is to move the cursor to the target area then write. So this part 2 is gonna to write to the target area repeatedly. Okay, part 3 we want to highlight this one is the match_wise treat. Match_wise is a system call, and the match we non need is the thing to tell kernel certain memory not in use anymore repeatedly. So you can see it will release the file size. And the part 4 is we back to the main function. I want to highlight this again. This two line is to run in parallel, so we can create a race condition. So here is to create race condition by running both threads at the same moment. Okay, so the whole part is we are running right thread and match_wise thread. So for the right thread, we want to do repeatedly to write, but first we have to locate a physical address with a copy created. Because of the count characteristic, so we have to haven't do any write, we just have the copy. So after create the copy, then we only can write to the copy, and match_wise is doing its thing to repeatedly tell the kernel certain file is no need. So these two will run infinity times. So this is the whole thing that we want the decal attack to achieve. We want to let the match_wise threads to interrupt into this locate a physical, and finally write the one to the read-only file. So this is the important result that we want to achieve in the cow attack. So come to the conclusion. The cow is a race condition exploit in the Linux kernel. So it can write to protected file or memory. And from that two tasks, we are successfully modify a read-only file and escalate the normal user to super user. Okay, thank you.